All right, thank you everyone for joining us today and welcome to today's webinar, How to Determine the Lowest Cost Joint Configuration. Today, Henry Lederman will be sharing with us on this topic, and before we get started, just a couple of housekeeping items. First, all users are in listen-only mode, so if you do have a question, please feel free to use the Q&A section. We'll be holding those until the end, whereby Henry and I will lead the webinar in a live Q&A. Now, today's webinar learning objectives are pretty straightforward. The goal is to help you understand how to produce cost comparison data for different joint configurations, how to mine the data to reveal opportunities for further examination, how to use preference optimization to gather a greater amount of information quickly, and finally, how to combine your analysis with bolt optimization for maximum results. Really, the whole goal here is to help you understand how to leverage this data to make better decisions on how to approach projects and how Qnect can help with that. So as I turn this over to Henry, Henry's background, for those of you that may not be familiar, he has spent over 47 years now in the industry as a detailer. He is one of the co-founders of Qnect and certainly has quite a bit of knowledge when it comes to this. Henry, we thank you for joining us today, and I will turn it over to you.
Thank you for your time today, and thank you, Aaron. Today, we will show you how to evaluate the lowest cost joint configuration, whether that be single angle, double angle, shear plate, extended shear plate, or some combination of those, and variations of bolts between 3/4 to 1.125". Why is this important? Well, it's the classic case of technology drives innovation, innovation drives efficiency, and efficiency makes us more competitive. Qnect is a powerful software that significantly impacts schedule while lowering costs. So for example, using Qnect, the lowest cost joint configuration will likely save anywhere from 20% to 50% of the bolts in a building. That's what we have historically seen job after job. So let's show you how it's done. And to do that, let's first start with a quick refresher of how Qnect works. You're currently looking at the Qnect website, and here we set up all the preferences that creates the parameters by which each joint will be designed. Connection type, forces, minimum requirements, fabricated detailing preferences, general bolt preferences, etc. So let's now, once that's done, let's now look at the Tekla model and how this process works. Now we're in a Tekla model, and when you download the Qnect app, you'll see buttons 1, 2, and 3. Now, we could run this whole building right now, and we'll connect maybe 80% of the connections. It'll take about 1 minute and 20 seconds. But we're just going to do one joint because we want to get to the optimization parts sooner. Just as a matter of perspective, we can run we've run a 4,300 ton project in 35 minutes, and we're currently being used on several 60-story buildings in New York City, where we ran 15,000 joints in 2.5 hours. So the speed is significant, and it allows us to examine the joint configurations for the lowest cost, because it can happen so early in the process, including, by the way, during the estimating stage, where you can get a real understanding and a handle on the joints themselves and the costs, and therefore your ability to price competitively. So let's start with this one joint. So what we will do, again, whether it's the whole building, one joint, one floor, one sequence, we'll select. We hit button 1. We find the job and the company, the name of the job, and we'll do the session. and submit. And again, because this is so extraordinarily fast, we generally would get an email that says it's ready, but we're just going to go right into the model. There it is, submit, and the connection is in the model. This also gives you a bit of a window into our ability to mitigate revisions that are caused by incomplete designs, changes, etc., by being able to make the changes generally about 3 per second. So here we have a standard connection. You can see it visually, it's about a 3-inch spacing. When we click on the cone, we get the general output, angle size, bolt size, etc. When we click on the strength, we will see the output, limit state results, block shear, tensile, rupture, etc. And when we click on the code, we will see the full AISE text, calculations, AISE references, etc. So that's a refresher as to the process. Again, this whole building would have taken about 1 minute and 20 seconds. Now I want to show you bolt optimization. And to do that, we're going to go back up to the website and we're going to activate bolt optimization. So Qnect will actually completely engineer every joint for the whole building for 3 inches, 3.5, 4, 4.5, 5, 5.5, 6. Full engineering. We'll compare the results and then select the vertical spacing with the fewest number of bolts. So we just have to say yes, we activate it, and then we come back to the website and we'll just observe that there's 6 bolts, and we'll delete this connection. And now we're going to run it for an optimized joint. Again, we hit button number 1, and we'll come in here, demo-7-17-2. We can call it BOP, or bolt optimization, and we submit, and we're good. Again, we're not going to wait for an email. Maybe it's there. It's not there yet. And we're just slightly too quick. Let's see if it's ready now, and it is. We submit, and connection is done. As you can see, the vertical bolt spacing has pretty dramatically changed from 3. This looks like probably 5 inches. But in the process, we have saved 33.33% of the bolts. We've met all the limit states. And so we have less bolts to purchase, double those number of bolts, fewer holes to drill, and less bolts to shop installed, and certainly less bolts to field install. So we're already starting to see some opportunities and some benefits through the bolt optimization. So that's your first. Now let's go to our second optimization, which is the preference optimization. So because the software is so extraordinarily fast, we can now examine many different joint configurations to determine the lowest cost. And while running the building, and the way we do that is by running the building 8 additional times with 8 different joint configurations, we can simultaneously do bolt optimization, so we can get the correlation between each different joint configuration with its optimization. So I'm going to show you that so it's clearer. So let's submit. And now we're going to come into the model, and we're going to delete this connection. And we're going to run it with both POP and BOP activated. So demo-7-17-3, POP and BOP. All right, and we'll submit. And now, again, the Qnect has grabbed the data, brought it up to its web servers, is running the engineering 8 additional times. And what you'll see here that it says the job is running. It's trying single angle, double angle, 3/4 inch bolt, etc. And already it's done. And once that's done, we will go to the reports. We'll find our demo that we just did, 717.3. We come in here, we do pop comparison, we hit the pop, and now we should see 8 runs. And here we are. We have what we call is the baseline run that we ask from our clients, which is the intended joint configuration they were going to use. In this particular case, it was a double angle. And then we have 8 additional runs using shear plates, with A490 bolts, double angle welded bolted. We're not limited to this group. This is a default setting. And often this informs other ideas of trial joint configurations, and so you can run as many as you feel necessary to get to the right joint configuration without any additional costs. So let's just examine this result. As you can see from here to here where it says standard, that represents the 3-inch spacing. And if we just looked at this group for 3-inch vertical spacing, we can see that our baseline created 18 bolts. We can get down as low as 6, obviously, shear plates. And we can get down, even with double angles, to 12. So we can easily, with other preferences, create a 33 1/3% difference. But the cumulative effect of material, shop labor, and field installation gives us our total here. Now, we are using unit costs from industry fabricators, which can easily vary with your geography. So you are able to put your costs on our website, or we will work with your estimating department so that you can take files from us that could then integrate with your estimating. We're working with several fabricators that have committed to our service, and we're integrating with their estimating process so that every job can be done this way, estimated this way, files transferred, and their competitive position strengthened. So we can see that 385 is the baseline. In this case, it looks like it's the highest. And we can get down as low as 227. But if the client doesn't want some of the welding, they have quite a variety of choices. Now let's move to the side where we've got bolt optimization, which primarily means the vertical spacing has changed, as we saw in the condition that we just previously connected to, maybe in that case about 5 inches. So if the client didn't want to change anything about their preferences, we can see that they can still go from 18 bolts to 12 bolts, a 33% variation by changing the vertical spacing, and for a cumulative savings of $104. So that's still pretty substantial. If they wanted to consider other joint configurations, then they can certainly get as low as 183 or even down to 260. And even at 260, we're saving $125, almost a third. And we're going from 8 bolts to 18, or 4 bolts from 18. So when you think about how fast this happened, there's a significant impact on the schedule side, and a pretty significant lowering of cost. One of the ways clients appreciate the time savings, when you think about how design drawings often come out too soon because the project needs to move forward. Schedules are very hard to keep because of all of the changes that come, RFIs that come, and so the time savings can really create an extraordinary buffer to mitigating schedule drift and managing all the changes with the speed of the software. So now I want to take this from one joint and show you some results of a job that we did, one of the many across the country, where we ran the preference optimization, as you'll see here. This is what the client was going to use as their baseline. We ran, for nomenclature purposes, beam to beam, single angle bolted, first priority, double angle welded bolted, second priority, and shear plate third, beam to column web, similarly beam to column flange, 7/8 A490, inch and 8 A490, and you could see a whole bunch of variations. Then we compared the cost for the 3-inch vertical spacing only, and we can see the client cost isn't bad, but we can save another $106,000. And when we examine the bolt optimization results, if the client wanted to stay with their preferences, they would still save $90,000. But if they chose the lowest cost, they would save $180,000. And with our information, this entire job used 1-inch A490, not something anyone would have imagined, evaluated early, because it takes extraordinary amount of computer power that only Qnect can provide to make this evaluation. But again, all of this is done either in the estimating stage, within the first day of the model being ready in production. So a lot of time to really mine the data for the best decision going forward on this project. A very amazing place to find oneself with the complexity of the projects and challenges that we face. Let me show you a couple other conditions that we were helping on the estimating side for a client. As we drill down further, we take that information that we just showed you and then break it down with angle, plate, weight, total weight, bolts, number of holes to be drilled, weld length, copes, beam, web coping, doubler reinforcing. Here is a job that we worked with the estimating on using their baseline of shear plates. Then, excuse me, we took the shear plate and optimized it. And as you can see, the plate weight went up. The total weight went up only 7%, which is really nothing. But the bolts went down 20%. We saved 1,400 bolts. The number of shop holes drilled doubled the amount of bolt savings. So we ended up drilling 20% less holes. The weld length went down just a little bit. And everything else was as you see. Then we said, let's try a single angle as part of another preference optimization. And we can see that the total weight cumulatively went up, in this case 22%. Again, not really significant based on the cost of material, but the bolts went down 6%, and in this case the weld length dropped 17%. It's pretty significant, from 48 to 40,000. So we're talking almost 8,000 linear inches of weld. But then we also tried single angle, again optimized. So this was single angle standard bolts, optimized compared to the baseline. Our total material went up 34%. Again, not significant, but it went up. The bolt holes, on the other hand, dropped 38%. So we saved about 2,600 bolts. That means 5,200 fewer bolts to be drilled, also down 38%. And the weld length went down almost 20%, 9,000 linear inches. The cumulative effect was a dramatic savings. Another one, the final one we'll show you. Baseline, double angle bolt, welded bolted. The baseline bolt optimized. The weight went down 7%. Holes and bolts went down 16%. Weld length went up just a tiny 3%. And then if we look at the results for single angle butt, we see a dramatic improvement. First, the total weight went down 47%, even though the angle weight went up. The share plate weight went down dramatically for a net reduction. The bolts went down 63%. So we saved almost 3,800 bolts, 7,600 holes, also 63%. The weld length also reduced 55%. So this is the sort of data that's available when you work with the Qnect software. Our arc of services start with estimating, where primarily there's no charge unless you win the job and use us. Production, revisions that are so fast, and the ability to mine data early to determine the lowest cost joint configuration. So with that, may I like to thank you for your time today.
What we'd like to do now is move into a section for Q&A. And we have a couple of questions already kind of queued up here from folks. If you do have additional questions, feel free to type them in the Q&A box. You'll see that at the, I believe it's the bottom of your screen. It says Q&A, and we'll roll through these. So Henry, first question is, when can we get this data? Is it only on a live project? And this was mentioned earlier, so I guess I can answer this one to start. The data that you've seen here is something that can be produced during time of bid. So if you have a set of design drawings and some early information, certainly we can get involved at the estimating phase to provide that information. If this is something that you think could benefit a live job, certainly we can get involved there as well. You know, really the extent of what we would need in that scenario is either a set of design drawings or a model from your team, and we can get going on that. Anything you'd like to add to that one, Henry?
Yeah, I would just say that, as I mentioned earlier, we're working with clients who are integrating us on all of their projects, on all of their bidding, and our field tech manager will work with you so that the data being provided by us is seamless into your estimating software. And so that's a high recommend and a good way to do it.
Yeah, good point. I actually was just on the phone with a fabricator who asked that question. They just moved over to EPM and asked if we could get KISS files, and obviously we can. All right, so we have a couple more that have come in. What do you need from me in order to get this information for a bid?
You want me to answer that, Aaron?
Yeah, go ahead.
Yeah, we need preferably an IFC file, which makes it easy for us to convert to a Tekla model. If it's not available, we'll take it. We always need a design drawings so that we set up the job to match the EOR requirements. Drawings, design drawings, IFC file, and we'll also send you a form to fill out that highlights your preferences, your joint configuration baseline preference, and then we can run that for you for the clients that we are integrated with in a long-term agreement. You know, they can do that themselves to any extent they wish, but that's what we would need, and that's how we would help you. Just give us a little bit of time before the bid date, and we'll pull it together for you. We'll also include, we carry the full connection engineering package, so we can add a quote for the Qnect plus 100% of all the joints, since we do about 60 to 80 P stamping, if that's part of something you need. Obviously, on the mandated jobs where you're being told what to do on the design drawings, we can mimic those, and you can at least have the data direct from the model instead of taking it off by hand. But same thing, IFC, design drawings.
Great, thanks. And I know someone hasn't asked this yet, but this is a good follow-up question to that, and that is, how do I identify what a good Qnect project is, right? And the answer to that is simply send us the design drawings, and we'll let you know if it's something that we think is feasible. We hold high integrity in making sure that our clients are successful, and so if there's ever a question, if we can help out, just send over the design drawings to us, and we'll let you know. All right, we got a couple more questions here. Can Qnect produce design calculations for each joint? So Henry, why don't you take that one?
That's precisely what we do. Is every single joint, we both engineer it, custom engineer it, and we create a Tekla component directly from Qnect that we place into the model. So yes, that in fact is exactly what we do. And then we summarize each individual joint up on the website, where you can create a submittal package that gets stamped with the full calculations on the project.
Great. Yep, and a follow-up question to that was asking about what detailing software this runs in. So as it stands today, the Qnect software sits on top of Tekla. So we work with Tekla structures. And so that is the detailing software that that we work with. Now, that wraps the last questions. Unless anyone else wants to sneak them in, feel free to type, and I'll wrap us up here. So if there are any additional questions that you have, please feel free to reach out to me. You'll see my contact information here. My name is Aaron Bartlett, and we will get you passed to the appropriate person depending on the question. Want to thank everyone again for their time today. Henry, thank you so much for leading us through this conversation, and we look forward to hearing from you. For those that are attending, again, thank you very much and have a wonderful day.
Thanks, Aaron.